Hello. So today we are going to start various kinds of cloud computing architecture. For example, Web 2.0, Mashup, RSS feed, Hadoop, HDFS, Storm, various Google architectures, Eucalyptus, Ruby on Rails. So first of all, Web 2.0. What are the Web 2.0 features? Like Web 2.0 host web pages, home pages, search engine are there, RSS are there, chatting, sharing are there, personalized websites are there, mashup means combination of various services are there, podcasting, videocasting, YouTube. These are the new technologies which came up in Web 2.0 to focus on community, online collaboration, taggings are there. So previously what happened in Web 1.0, only HTML pages and some database were linked through that HTML pages. So these two things are only the part of Web 1.0. But as the technology growth take place and new things came up. So the Web 2.0 had search engines, various personalized websites could be created, mashup could be created, means combination of various services. Podcasting means the communication that we are doing. Video casting, YouTube, communities are being focused. Online collaborations are being done, taggings are being done, RSS feeds are being done. Then what are mashups? Mashups are basically phenomenon to create a new service on web with a combination of presentation data and functionality of two or more resources and services. So various resources are being combined according to the presentation data and functionality to create new web service. Then what are the benefits? So it create innovation, and it is innovative that how you combine two three services together. It improves business, it improves agility, speed up in development. Means if process one, service one needs to followed by service 2, then service 2 is being followed by service 3. So it's easier if you have combined all the first, second, third service. So it reduces cost of development, and it is easier and fast for integration. So various widgets are being came up. It makes service 1, service 2, service 3 more reusable as compared to making a combined web service. Then it is immediate benefit, means you get the benefit at the earlier level. So less cost over there. It's rich in ecosystem, and more that original raw data are there. And then you have better results, data and services. So mashup is basically divided into three different layers. It is an obvious. First one is presentation. HTML, XHTML, CSS, JavaScript, Ajax API. So all these things are the presentation level. Then web services level are like XML HTTP request, XML RPC, JSON RPC, SOAP, REST. These are the web services. Then what are the data? The data are basically for sending, storing and receiving purpose. The technologies which are being used are XML, JSON, KML. So these are the three different type of technologies that are being used in the mashup: presentation, web services and data. Then RSS feed, what does RSS feed means? RSS is basically XML language for syndicating subscribed content on web, so that you can have subscription of some website or some organization or some reporting web pages or something like that. So you can have news as the RSS feed. and for that XML language are being used. Then you what how you can do that? You simply register on an organization and accept their all the agreements, and then you can create an RSS feed, so you get the updated automatically RSS feed notification on your emailing system, or some your own web page or something like that. Then you have the information that are being received quickly at a particular single location, so that you can have a mashup like with the help of with along with RSS feed. So mashup along with RSS feed. This is what you can create and at the same location. Then next we'll discuss about Hadoop. Hadoop was been invented by Doc Cutting. He is basically a developer of Java, and he is advanced software engineer. So he developed a Hadoop, which is an open source, reliable, scalable for distributed computing. So Hadoop is a kind of middleware, and it is been named after his son's toy, which is a elephant, a small elephant, and that elephant is named as Hadoop by his son. So the software library and framework of Hadoop is basically of Java, and it has locality of reference for distributed processing of large data set across the cluster of the computers using simple programming model. These are the uh, properties of this Hadoop, means distributed processing could be done for the large scale data across many computers connected through some cluster with some simple Java based programming model. So for that, software libraries are being used, frameworks are being used, then locality of references are being used. What is the IP of that computer where a particular data need to be processed? Scalability means scale up from single server to the thousands of machine, and it offers local computation. So program remains same for the 10, 100 or thousands of node. So the computation keeps on increasing with the number of nodes. Corresponding performance improvement takes place. So the improvement depends on the number of nodes. Then some of the things are fault tolerant and for the file system. So you can handle and detect failures. If you have some failures and you can detect it, then delivery could be highly reliable. It's possible to have delivery, better delivery. Then Hadoop distributed file system HDFS could be the one distributed file system where the processing is actually taking place. Then modeling of the Google files. So the Google file system. So it is based upon the HDFS is based upon Google file system. Google file system came earlier as compared to HDFS. So earlier starting was being done by the Google file system. Similar model and architecture are being replicated and copied to the HDFS. So HDFS and GFS are almost similar type of distributed file system. Then what they both do, HDFS and GFS, they do the map reduce for the parallel computation. Some components of Hadoop are like Pig, Hive, HBase, Zookeeper. Then you have the architecture, basic architecture. So what does this HDFS architecture says? So there is a name node, and in that name node there are many. There's a name node which is master computer. Then there are various slave nodes which are named as data node. So data node actually contains data, and name node contains indexing. And indexing is being kept in the metadata, means what is name of that block, replication, how many replication, what is path of that block, data block. So that data block is basically kept in the data node. What happened actually? Client asks for the name node, means I want this type of metadata, and that metadata has been information has been given to the client. Once the client get the metadata information, client can automatically get the uh, the data node after this. So client start fetching the particular data node. And what is meant by replication? So replication means copying the particular data node, particular block of data into multiple rack of data nodes. So you can see rack 1 and rack 2 are there. So suppose rack 1 is kept at Bangalore and rack 2 is kept at Hyderabad. So you keep replicating the same data of Bangalore to the Hyderabad. Why you do this? Because suppose if certain incident and happens, because of what, the data of Bangalore was been lost. So but you have the same data replicated at Hyderabad, so you can copy the content from Hyderabad back to Bangalore when Bangalore server comes up. And this is what we discussed. Name node is master, and secondary node is, or slave node is, basically data node. So the secondary node is also name node could be created, but in general there is a one n- name node in smaller computation. So if there is large computation, then there will be three name nodes, and you can have multiple slave node working for them. I hope this is pretty clear to all of you in distributed computing master slave model. And next we'll discuss the specific feature and the content and all these things in the name node, data node, and how they are being done, what are the features, what are the blocks, what are the heartbeat, block report, replication, data integrity, rebalancing. So name node, what name node does, it do the management of file system, means mapping the files to the block and blocks to the data node, as we discussed just now. Name node manages status of various data nodes, means there are 5 data node, 10 data nodes, and in that data node, what are the address of that block in that data node, what are the mapping of that block. So all these things, some of the information are being kept in the name node. Then what are the heartbeat? Heartbeat is that the data node sends the heartbeat at the regular interval. So all the data nodes keep on sending their heartbeats. Then heartbeats are being accepted by the name node. If some heartbeat is not received, means from a particular data node, so data node is declared to be dead. Means suppose Bangalore server is down, so its heartbeat do not go to the master server or name node at Delhi. So the Bangalore's servers heartbeat do not go to the Delhi, so it will be declared as Bangalore server as dead. This is what it means by heartbeat. Then block reporting. So the data node basically sends a list of blocks. So what are the blocks in that particular data node? And it is used to check the health of HDFS. So basically, full file system of distributed file system are being checked with the help of this list of blocks, and sent by the data node to the name node. Then data node basically do what? Data node basically do replication on data node based on failure, on disk failure, on block corruption. So if there is some failure happens, or some trouble happens, corruption happens, so the replication may takes place, means between the data node, and various disk failures are being possible, so block corruptions are being possible. So the replication keeps on happening between multiple racks or multiple data centers, so that you will have at least one copy saved. Then data node also do data integrity, means checksum and store in the hidden file. So whether the data stored is correct or not is being maintained by some checksum that you have studied in the computer networks, and for that you do the data integrity by the data node. What data node do? Data node also do rebalancing. In data node, balancer tools are being attached, which actually add a new node based upon the uh, s- new machine came up, and it actually decommission or delete some of the files from the particular node and transfer it to the another new data node or some free data node. So rebalancing are being done at the data node level. If there any doubt or any question, then you may. So I hope till now these all the things are been clear, and we'll move next. How the data are being replicated. The data are being replicated according to the name node uh, metadata, or you can say index. That file names are there, number of replications are there, then block IDs are there. What are the block ID? So suppose user Samir RP data part 0 is being replicated two times, where at 1 and at 3. So what 1 and 3 means? Part 0 is basically 1 and 3, and then you have the another part 1 is being replicated 3 times as 2, 4 and 5, so that you'll have the two parts replicated. So I hope this has been clear that these are data node, various blocks are there, and one is being replicated at two places. Okay, and 3 is also being replicated at two different places. 2 is being replicated at three different places. 4 is being replicated at three different places, and 5 is being replicated at three different places. So the combination of 1 and 3 creates part 0, and combination of 2, 4, 5 creates part 1. Then what is map reduce? We'll study map reduce word count today. Then we'll see some other things in the next class. So the map reduce part is basically simple thing. I hope you are clear about hash map functions in the Java programming. Hash map is a very common data structure nowadays for doing the advanced level computing. So the hash map, if you know, so you can easily understand key and value pairs. So key and value pairs are being easily understood. So the map reduce have basically input and output both in terms of key and value. So the map is basically having key one and value one, which are being listed as key two and value two. So how it is being done, how the mappings are being done. So you can see in the right hand side, there's a big rectangles. In that various tasks are there. So the tasks are being done by two different persons. One is provided by the user means you are the programmer and you do the task. And in the right hand most side, so it is these features are being provided by the Hadoop framework, and these features are automatically done by the Hadoop. So what you need to code, what you need to program, you need to program job configuration. Means you want to involve these machines, this data, and these are the number of iteration you want to do. Means some of the job configuration, whatever it depends, you do that. Then second step is input format. Means what is the input format? It is text, it is image, so binary. So you need to think what is the input format and which are allowed by the Hadoop. Then the input format goes to the input splitting and distribution. So the input location also you provide that hard drive. This is the location. Basically, in the Hadoop distributed file system, the files are being like a URL. So you provide the URL for the input location, and that input are being splitted and distributed. Then what happen at the next level? At the next level, you start doing the programming for the mapping part. You do the map function, you create map program, and then this map goes to the Hadoop framework and it just starts doing individual map tasks. This task was been done by the Hadoop. So mapping is being done by the Hadoop, but according to the logic and the code that you had given. Then thereafter, it basically shuffles and partition and sorts the map output. Means all the mapping of key and value pairs are being shuffled based upon the key, and it has been partitioned out. Means machine 1 will process first 10 keys, machine 2 will process next 11 to 20 keys, machine 3 will process 21 to 30th key. So this splitting and partitioning was being done by the Hadoop by itself. Then what it does the merging, that out of 1 to 10, 5 keys are being merged. Out of 10, 20 to 30, 5 key are being merged. Then from 21 to 30, 8 keys are being merged. So these are the merging techniques which are being done at the Hadoop level. So what you have to do, you have to, as a programmer, you have to give the number of reduce tasks after that. What are the number of reducers are being required? Then you write the reduce function, means you do the coding for the reduce function. So there's only two coding, logical coding. You have to do map coding and reduce coding. Then that reduce function will start reducing at the individual level. Means at machine 1, machine 2, and machine 3. All the results are being combined and reduced into the single machine. And then the result will be stored as the collection of the output file. So collection of output file are being stored. How this has been stored? You need to mention what are the value types, means what are the format, what are the means image or some binary, again text. So what are the input type you have to tell, what are the format, output format you have to tell, what are the how the presentation of output should be done, and then you just mention what should be the location where you have to store that file. Then MapReduce will not work for basically three different complicated tasks. So this MapReduce will not work for the inter-process communication, that some inter-process communication won't work. Data sharing is required. Recursive functions are being required. So data sharing, recursive function, and inter-process communication do not work in the MapReduce. Thereafter, word count is basically example that simple word count we'll see, and you have to code these two things, mapping and reducing. These two are the most important code that you have to write. So basically you have various input as text document and text are being broken into various words that you have to do with the Java, normal Java codes. And you have various outputs for the each word, means every word will have value 1 in the starting point, and it's very simple. Each word are being broken with the space or some comma or something like that, and after that you just put value as 1. Thereafter what you do, you do the reduce, means how many times that word is being occurred. So you keep an adding, means plus value, means value equals to value plus 1, value equals to value plus 1. So every time that word occur, you keep on incrementing that count. So this plus value is basically counter for that word. So overall map reduce processing you can see over here. So input is like deer, beer, river, car, river, deer, car, beer. So the three lines are been broken into three different splitting part, like deer, beer, river are first split, car, river as second split, deer, car, beer as second split. So basically it will go to the machine one or just in the single machine, whatever be the configuration you do. So the three split will take place like this. So in the mapping, that the code that you have done, after that deer comma 1 will be stored, beer comma 1 will be stored, river comma 1 hash map will be created. So thereafter second hash map will contain car comma 1, car comma 1, river comma 1, deer. Third hash map will contain deer comma 1, car comma 1, beer comma 1. So this part is of mapping. Thereafter, shuffling was being done by the map reduce. So the splitting and shuffling was being done by the map reduce. So the shuffling being done by the map reduce, then you merge this beer from the split 1 and split 3. So beer are being shuffled and merged at the part 1. Thereafter, the car are being merged from the split 2 and 3. Then deer and deer are being merged from the split 1 and split 3. Then river are being merged from the split 1 and split 2. Thereafter, you just combine. Beer is counted for 2 times. Car has been counted for 3 times. Deer has been counted for 2 times. River has been counted for 2 times. So the beer is occurring 2 times. Car is occurring 3 times. Deer is occurring 3 times. And river is occurring 3 times. So this counterpart word comma plus value is the reducing part that you had written in the code. Then the final result are being generated as the output, and you will get the output with the format and everything. Then in the next class we'll see the similar architecture of Storm. Thanks.